Imagine standing before a mirror that refuses to show you the present. You raise your hand, but nothing moves. You lean closer, but your reflection does not follow. Instead, something else appears, something ancient, something that existed long before memory, before history, before time itself felt meaningful. This is not a mirror made of glass. It is a mirror made of light. But not ordinary light. This light has been traveling for billions of years, crossing distances so vast they defy comprehension. It carries with it fragments of realities that no longer exist. What you are seeing is not what is. It is what once was. Every faint glow in the night sky, every distant shimmer, is a message encoded in photons, tiny packets of light that began their journey long before Earth formed, before oceans gathered, before life ever sparked into existence. This is not reflection. This is time unfolding itself before your eyes. And this is the true purpose of the most powerful space observatories humanity has ever built. They were never just about seeing farther. They were about seeing earlier. For decades, scientists believed they had a clear picture of how everything began. The universe, according to our best models, emerged around 13.8 billion years ago from a state of unimaginable density and energy. Space itself expanded, carrying matter and time outward in all directions. In those first moments, everything was hot, chaotic, and formless. But as the universe expanded, it cooled. Energy transformed into particles. Particles formed atoms. Hydrogen and helium drifted through a vast, dark cosmic ocean. Then came a period known as the Cosmic Dark Ages. No stars. No galaxies. No visible light. The universe existed, but it was hidden. Slowly, gravity began shaping that darkness. Tiny fluctuations in density grew over time. Matter gathered into clouds. Those clouds collapsed, becoming hotter and denser until, deep within them, something extraordinary happened. The first stars ignited. They were unlike anything we see today, massive, unstable, and short-lived. They burned with incredible intensity, flooding the universe with light for the very first time. From them came the earliest galaxies, primitive structures that, according to theory, should have been small, chaotic, and disorganized. The expectation seems simple. The further we look into space, and therefore back in time, the simpler the universe should appear. But reality did not follow expectation. As observations pushed deeper than ever before, something unexpected emerged. What once appeared faint and unclear suddenly revealed detail. Structure. Organization. Galaxies that should have been in their infancy appeared far more developed than predicted. Some showed rotating disks. Others had dense, bright cores surrounded by organized systems of stars. A few even hinted at spiral-like patterns, structures that should not have existed so early. It was as if the universe had grown up too quickly. At first, there was skepticism. Perhaps the measurements were wrong. Distance in astronomy is often determined by how much light has stretched as space expands. If that interpretation was flawed, then these objects might not be as ancient as they seemed. But observation after observation told the same story. These galaxies were real. And they existed astonishingly early, only a few 100 million years after the beginning. In cosmic terms, that is almost instantaneous. Like discovering a fully built city where only foundations should exist. Then came another surprise. Light does more than reveal shape. It reveals composition. By analyzing it, scientists can determine which elements exist within distant stars and galaxies. And what they found was unexpected. These early galaxies already contained heavy elements, carbon, oxygen, nitrogen, even iron. But such elements are not created at the beginning of the universe. They are forged inside stars, then scattered into space when those stars die. This process takes time. Generations of stars must live and die to enrich the universe. And yet, somehow, it had already happened. This suggests the early universe was not slow or gentle. It may have been intense, rapid, and violent. Stars could have formed quickly, lived briefly, and exploded, enriching their surroundings far faster than we ever imagined. A universe not gradually evolving, but racing forward. The mysteries continued. Massive black holes were also found to exist far earlier than expected. Some had already grown to enormous sizes in a remarkably short time. According to traditional understanding, this should take billions of years. So how did they grow so quickly? Some theories suggest they formed directly from collapsing clouds of dense matter, skipping earlier stages. Others propose unknown mechanisms that accelerated their growth. But no explanation has yet been confirmed. Which means something fundamental may still be missing. Even the shapes of these early galaxies raise questions. Instead of chaos, many show order, symmetry, coherence, patterns emerging where randomness was expected. It is as if something unseen influenced their formation. Invisible matter, matter that does not emit light but exerts gravitational force, may play a deeper role than